All right, so our question says a deionizer is a device used in rooms where workers build sensitive electronic circuits. A deionizer contains a small block of polonium 210. Complete the equation that shows the alpha decay of polonium 210 into lead 206. You just have to complete the equation. So, what numbers should I write down? Shreya, can you tell me what numbers I should write down over here for the alpha particles?
So will the first one be 4?
Yes, correct.
And then the bottom one would be
8.
2.
2, yes.
Yeah.
Correct, correct. All right. Now they're saying the alpha particle ionizes air molecules in the room. State what is meant by ionization. Whereas, what is ionization?
I don't know.
Okay, Shreya, do you know what is ionization?
Mm,
Okay, ionization is the process where an atom turns into a ion. That's it. That's all ionization is. That's why this is only for 1 marks. The process by which an atom turns into a positive or a negative ion. Okay, that's all ionization is. A process that turns a positive or that turns an atom into a positive or a negative ion. Now they're saying explain why workers in the same room as the deionizer are not at a risk from the alpha radiation it emits. So this deionizer is producing alpha radiation. So workers who are working in the same room are not at a risk. Why? Viraj, can you tell me why the workers are not at a risk?
Alpha particles do not travel that far.
Yes. Alpha particles cannot penetrate. Don't say they don't travel very far. Say that they cannot penetrate through the into the worker's body. Okay, they cannot penetrate into the worker's body. So over here, you're going to say two things. You'll mention, Viraj. One, that alpha particles are highly ionizing. Okay, so because they have high ionization power, so they will be unable to penetrate through the worker's skin and cause any internal damage. Good. The half-life of polonium 210 is 140 days. State what is meant by the term half-life. Shreya, can you define half-life, please?
It's the time taken for I
Yeah,
forgot
yeah, yeah.
like the like it's like the time taken for something to like not be radioactive anymore.
Okay. It's okay. I'll write down the definition, right, Shreya? And you guys can give the same definition each and every time. Okay. The time taken for the radioactivity of a sample to decrease by half. Okay, this is how we define half life. It's the time taken for the radioactivity of a sample to decrease by half. How long will it take for the radioactivity to become half of the previous value? Okay, that is going to be half life. Now they're saying the initial activity of polonium 210 source in the deionizer is 770 kilo PQ. Calculate the activity of the source after 420 days. So you have been given the half life, it's 140 days. You have to figure out the activity after 420 days. Okay. Would you guys like me to go over this question with you, or would you like to attempt it yourself?
Can you
Would you
go
guys like me? Would you
over
guys like to attempt this yourself? Sorry, Viraj, I'm sorry I couldn't hear you. What did you say?
can you go with this? Like, I don't know how to do.
Yeah, definitely. Okay. So the way you are going to go, Ashreya, if you would like to solve the question yourself, then you can just put me on mute and you can solve it yourself. Okay. If you or if you want me to go it with you, I'm going over it. If you don't want me to go it with you and you want to try it yourself, then you can just mute me. Now, Viraj, basically, our half life is 140 days. Okay. That means our starting activity is 70. Okay. Now, when we do half of 70, what do we get, Viraj?
35.
35. How many days will it take for it to get from 70 to 35? 140 days. Okay. Then, can you do half of 35?
Wait, how do you know it takes? Oh, okay, never mind.
It's given in the first part of the question. So if you do half of 35, what do you get?
17.5.
17.5. And this is again going to take another 140 days. So how many days do we have in total? Like 140 plus 140 gives us
240. Wait, 280. Yeah, 280.
280. So we have to continue. They said until 480 days. So we will continue until we reach 480 days. Now, 17.5 again divided by 2. What do we get?
I don't know, but like 8.25, I think.
Okay. I'm not doing the calculations either. I'm just trusting you with it. I think it'll I think it might be 8.75 though. Yeah, I think yes.
Yeah, it is 1 point. Yeah, it is 1.
8.75. It should be 8.75. So this will take another 140 days. So now add up the three values and see if we have reached 420 yet.
Yeah, we did.
We did, right? So that means after 420 days, it's going to, what is going to be the count? The count is going to be 8.75. That is your final answer. Okay. Now, another way of approaching the same question, Viraj, is that you figure out how many half lives are needed. Okay. So the way you solve the question is like this, that one half life is 140 days. So how many half life are in 420 days? You can also approach the questions like this. One half life is 140. So how many half lives are going to be in 420 days? So you solve 420 multiplied by 1 is 420. This is equals to 140x. So x is going to come out as 420 divided by 140. X is 3. That means it will take 3 half lives for the act in for 420 days. Okay. For 420 days is going to have 3 half lives. 420 days are equal to 3 half lives. So you know that you have to divide the value 3 times. That's it. So you can just divide the value 3 times. 70 divided by 2 gives you 35.5. Then 35.5 again divided by 2 gives you 17.5. 17.5 again. Also formula you guys can use. 1 divided by 2n multiplied by radioactivity. So the number of half-lives are 3. So n is going to be 3. The initial count is 70. So you can do 2 cube is 8. So 1 divided by 8 multiplied by 70. You will again get 8.75. Okay. So there are a few ways of solving questions like these. One way of solving questions like these is that you simply keep on doing the half-life. Okay, so if they've asked you after 420 days, so keep on dividing it by 2 until you get 420 days and you will get the count. Okay, another way of doing it is by finding the number of half lives. To find the number of half lives, you will simply do one half life is 140. So how many half lives are there going to be in 420 days? So we get 3, right? So that means in 420 days, 3 half lives would have passed. So you can simply use this formula then. 1 divided by 2n multiplied by whatever the radioactivity is. So n is going to be the number of half-life. So 1 divided by 2 cube multiplied by 70, and you'll get the same answer, 8.75. Use whichever method you guys find easier. If you find it easier to use the formula, use the formula. If you find it easier just to keep on dividing it by 2 until you get to the value, do that process. This method where you just keep on dividing it by 2, right, until you get the answer, this method is okay in your IGCSE level, mostly because they they don't give you very complicated questions, right? For example, 420 days is just 3 half lives, so you just have to divide it 3 times. But if you get a tricky question where there are, many half lives, 10 half lives, 20 half lives, then that will take you ages. So it will easier to use the formula and questions like that. Okay, I hope this is making sense to everyone. Viraj, Shreya, is this making sense? What are the two approaches for answering these questions?
Yeah.
Yeah.
Okay, let's take a look at our next question. One second. Okay, your question says a teacher investigates the penetrating ability of gamma rays from the gamma source. This is the teacher's method. You guys can read the method yourself because then you'll be able to understand it better if you take your time to read it. So go ahead, take your time to read the method, and you have to tell me first of all the answer to part A. Name a suitable radiation detector that this teacher could use. Shreya, can you tell me the first one is easy? Can you tell me the suitable radiation detector that the teacher can use?
The GM tube.
What did you say, Shreya?
The GM tube.
Yes, the GM tube or the GM counter. Now, okay, now go ahead, read the teacher's method and give me the answer for part B. Are you guys done yet reading the question? When as soon as you guys finish, somebody tell me, Viraj, you tell me what is the independent variable in the teacher's investigation.
Which question am I supposed to do? The first one.
The no, the first one, Shreya has given me the answer, right? The second one. The first one is the
Oh,
GM
okay.
counter, right? The second one,
Oh, yeah.
independent variable.
Oh, okay. The gamma source.
No, she's using the same source throughout, or you should use the same source throughout actually.
Or the absorbing materials then.
Yes, exactly. The independent variable is the variable we are changing. So what are we changing? We are changing the absorbing material. Okay, so the independent variable over here is the absorbing material used. Okay, explain why every absorbing material used in the investigation has a thickness of 1 centimeter. Shreya, can you tell me why is it that every absorbing material that we're using, it has the same thickness, that is 1 centimeter?
Because if we use the same like
Mm-hmm.
1 centimeter thick absorbing material, the experiment is like
Yes, yes,
valid.
you're
Like
on
it
the
will
right.
be
Yes, you're right. It's going to be
uh
yes, the experiment will be valid.
valid. Yeah.
Yes, our experiment is going to be valid. How is it going to be valid? It's going to be valid because we are basically controlling our variable, right? So by this is going to act as a control variable, and it's going because okay, Shreya, over here you can just give a little bit of detail. You can say that because different thickness of the absorbing material will affect the radiation count. So to make the study valid, we keep the thickness as a control variable. Correct. Okay. Now they're saying suggest one improvement the teacher could make to this method. Viraj, can you give me an improvement? Oh, there is one major improvement that can be done actually that I can think of.
Improve the read radiation detector maybe.
Um, no, 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 we're not going to talk about that. No. Think of a improvement in the method, not in the equipment, not in the instrument, in the method.
I don't know.
Shreya, can you think of something? Okay, one thing that you can do is subtract the background radiation, right? Like if you remember, that was one of the major things that we often have to do. What is one of the major things we often have to do? Subtract the background radiation. So that is something you can see that the teacher is not doing, right? They're not subtracting the background radiation from it. So we have to make sure that we subtract the background radiation. Secondly, she's saying repeat the measurements 2 more times. So you can say that use the measurements to take out the average, or you can say plot a graph of absorbing material against the count rate, right? So these are the points you can add. Subtract background radiation. That's a very important point. Remember that, always subtract background radiation. And then you can talk about taking an average, and then you can talk about maybe making a graph. So improvement to the method means the method, not the material or the equipment. Okay. The table shows the teacher's results for 7 different absorbing materials. On the grid, plot a bar graph of the mean count rate for each absorbing material. Please go ahead and take a screenshot of the table. Let me know when you guys are done.
Done.
Okay, give me 1 second. Let me share. Give me 1 second. Let me share the graph with you. I want you guys to go ahead and draw the graph over here. All right, there you go. Okay, Viraj, you can go ahead and draw it on the. Viraj, you can go ahead and draw it over here. And Viraj, you can draw it over here. And Shreya, you can draw it over here. Take 5 minutes. Don't take more than 5 minutes. Okay.
So I have to draw the mean and also a bar chart. Okay, my bad.
Oh, sorry guys. Sorry, my this thing got disconnected. I'm so sorry. All
All
right. Okay. It's okay. I think you guys were drawing the graph. I'm so sorry. It did this disconnected my screen sharing thing, and the graphs are not there anymore. So it's okay. I was checking your graphs while you guys were drawing it, so they seem fine. So we can move on. Okay, they're asking you why is a bar chart the correct way to display the results? Who is going to Viraj? Can you tell me why a bar chart is the correct way to display the results?
because I
Viraj?
think absorbing material is not a continuous variable.
Yes, because absorbing material is not a continuous variable. Okay, when we talk about our variables, okay, Shreya, especially I think because I don't know if I know I've done this with Viraj in biology, but I don't know if I've done this with you or not. There are two types of materials that we can have. Okay, we can have discontinuous variable and continuous variable. Discontinuous variable, when we are going to talk about it. So discontinuous variable is variable that is categorical. Okay. So meaning that this variable can only be in certain categories. So like over here, the absorbing material is categorical, right? Like it can either be aluminum or lead or paper or so on and so forth, right? There's certain categories. Like your blood group. Your blood group can be A, B, or AB, or O, whatever. So this is categorical data. We call this discontinuous variable. Then we can have continuous variable. Continuous variable is variable that can have any numerical value, right? Like if we talk about example, so examples of this would include your radioactivity count. Okay, count rate is a continuous variable. It can have any numerical value. Your height, it can have any numerical value. Your weight, it can have any numerical value. Your age, it can have any numerical value. So over here, absorbing material is not a continuous variable, it's a discontinuous variable. Why? Because it is in categories. Okay, count rate is a continuous variable. Okay, so whenever our independent variable is a categorical variable, or whenever our independent variable is in categories, we use bar graph. Okay, Shreya, I hope that's making sense.
Yeah.
Okay. Now they're saying a student concludes that plastic is the best absorber of gamma radiation because plastic gives the largest mean count rate. Evaluate the student's conclusion. This is what the student is saying. He is saying because plastic gives you the highest mean count rate, so plastic must be the best gamma ray absorber. You guys have to evaluate, right? Meaning that so what do you guys think? It's just for 2 marks. You don't have to give a long answer. What do you guys think? Is the student correct? Yes or no? And if he is not correct, why? If he is correct, why? Do you guys think plastic is the best absorbing material?
Wait, isn't like the lowest
Yeah.
mean rate gonna have
Yes.
the best thing?
Yes. 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 Yes.
Because that means that it has let
Yes.
less radiation to pass through, yeah?
Yes. You are
That's
right.
gonna be what, lead?
Yes, lead is the best absorbing material because if the material is absorbing the radiation, if it's absorbing the gamma radiation, the mean count should decrease. The radioactivity should decrease because why should the radioactivity decrease? Because the gamma rays are being absorbed. So if the gamma rays are being absorbed, our radioactivity should be decreasing, right? So lead is the best absorber because the count is the lowest after lead. So the student is incorrect. Okay, let's take a look at our next question. 1 second. The question says, this question is about food preservation. The diagram shows how a gamma radiation is used to I'm so sorry, food stored in a wooden box. The radiation kills bacteria on the fruit. Explain why gamma radiation is used instead of alpha radiation to kill the bacteria. Shreya, can you tell me why I'm using gamma radiation and not alpha radiation?
Um, because like they have a higher penetrating like power, which means um,
Mm-hmm.
and they have like shorter wavelengths, so they can like kill the bacteria faster.
Uh, okay. When you talk about your alpha particles, okay, tell me for the alpha particles, do they have high ionizing power or low ionizing power?
I forgot.
Okay, it's okay, no problem. They have high ionizing power. Okay, what does that mean? Now, do you remember that? Okay, between alpha particles and gamma particles, which is more penetrating, right? Like, which one can cross more materials? Gamma radiation, right? Gamma rays are more dangerous. That's why gamma rays are more dangerous. Why are gamma rays more dangerous? Because they can actually cross through uh, any material. You need very thick amount of lead to absorb that gamma radiation, right? Gamma radiation have low ionization power, but high penetrating power. So they can easily pass through the wooden box and go to the fruit and destroy the bacteria. On the other hand, alpha particles are highly ionizing, meaning that they cannot penetrate, they cannot pass through the materials. One piece of paper is more than enough to stop an alpha particle in its path. Okay, so the alpha particles will not be able to penetrate through the wooden box. So then obviously, how are they going to help in destroying the bacteria? Got it? Making sense now?
Yeah.
Okay, next they're saying to you, the wooden box has this labeled. These fruits have been irradiated. Explain why fruit irradiated with gamma radiation is safe to eat. Why is it, Viraj, can you tell me why is it safe to eat fruit that has been radiated with gamma radiation?
Because it has killed all the bacteria.
Yes, because not just because it has killed all the bacteria, you are right, it would have destroyed all the bacteria, but why is it safe to eat, in the sense that why don't I have to worry about radiation damaging me? Why don't I have to worry about the radiation damaging me? Why is that not a concern, that the radiation can also harm me, right? Why am I not stressed about that? Why am I not worrying that, oh, the radiation can harm me as well?
Is it because they have low ionizing power?
Mm, yes, because you're right, because they have low ionizing power. So because they have low ionizing power, what is going to happen? That your alpha particles, basically, okay, your gamma waves, right? Because they have low ionizing power, so they will simply leave our body. They will simply pass through our body without causing any damage to the internal structures. Okay, that's what I told you guys, that if gamma radiation comes from outside the body, it can be very dangerous, because it can penetrate through the skin and harm the cells inside the body. On the other hand, if the same gamma radiation, it comes from inside the body, meaning that I have eaten something that is gamma radiation inside it, so then it is not that harmful. Why is it not that harmful? The reason it's not that harmful is simply because of the fact that uh, it has low ionizing power. So it's not going to hurt or damage the cells of my body that much, but it will simply leave my body quickly. Okay. So that is what you had to know. Now take a look at another question. Okay, this is a nuclear reactor. The diagram shows a nuclear reactor. Each part of the nuclear reactor has a function and is made of a suitable material for its function. We have to complete the table by giving the missing information. Okay, so over here, let's go ahead and let's discuss the structure of a nuclear reactor. Okay, so when we are talking about the structure of a nuclear reactor, we have in front of us a few parts. Okay, so when we talk about we have a control rod, we have shielding. Shielding is obviously acting like a shield. It's the it's protecting the it is acting as a shield and protecting us from any harmful radiation. Then over here we have a control rod, a moderator, a fuel rod, and then we have our coolant system. Okay, so when we talk about the control rod, the control rod, why do we need a control rod and what is the function of a control rod? We need a control rod because a control rod is going to a control rod is basically going to help us in absorbing any excess neutrons that are produced in the reaction. If you remember what reaction happens in nuclear power stations, nuclear fission, right? And in nuclear fission, when nuclear fission happens, what happens that the uranium particles break down to give you your uranium nucleus, right? The uranium nucleus breaks down to give you your smaller particle, which can be boron or krypton or whatever, and along with that it also gives you neutrons. Now the thing is that we want the reaction to be controlled. We don't want an uncontrolled reaction. I told you guys it's a chain reaction. Once it starts, it's going to keep on happening. We need some way of controlling it. We need some way of keeping it in check, because if it's just going to keep on happening and happening and happening, then how is that going to help you and me? Okay, so for that we need control rods. Control rods will stop the neutrons. That's the function of the control rods. They will stop neutrons from traveling between the fuel rods. Okay, they will stop the neutrons from traveling between the fuel rods. Okay, so because if we don't stop that from happening, what will happen that the neutrons, if they travel between the fuel rods, then the chain reaction will keep on happening and happening and happening and happening, right? So how do we stop the reaction from happening? We stop the reaction from happening by using control rods. So if I want the reaction to finish, if I want the nuclear reactor to stop reacting, I will simply lower the, you can move these up and down. So I will lower the control rods. They will absorb all the neutrons and the reaction will stop. Okay, then we have moderator. What is the function of a moderator? It slows down the neutrons. Okay, the control rod completely stops them. The control rod stops them or absorbs them. The moderator on the other hand slows them down. Okay, it slows down the neutrons so that the control rod can absorb them, because the neutrons are extremely fast moving. So if you don't do since they're so fast moving, so for us to have for us to stop them, for us to to absorb them, we first need to slow them down. So the moderator will slow them down. And then we have our fuel rod. Fuel rod is basically what provides us with our fuel. Okay, so this is normally made of like your whatever your fuel is. So if our fuel is uranium, then it's going to be made up of uranium. Then we have our shielding. So the shielding protects us against radioactive hazards. If there's any radioactive compounds produced in the nuclear fission reaction, it protects us against that. And then obviously we have our coolant. What is the function of the coolant? The coolant is when, so what is going to happen that this coolant is going to get heated up during nuclear fission when energy is going to be produced. Okay, during nuclear fission energy is released, so that energy is going to heat up the coolant. Okay, that coolant, when it is going to heat up, it is going to be used to boil the water. and then that will produce steam. And then we use steam to rotate turbines and generate electrical current. Okay, so this is coolant is simply to absorb the heat that is being produced in the nuclear reactions. Okay, these are the parts of your nuclear of your nuclear you can say our our these are the parts of our nuclear uh nuclear reactor. All right, take a screenshot of this, keep this safe with you. These are the parts of the nuclear reactors and these are their uses. Is everybody okay with what we have discussed? We all understand the different parts and functions of a nuclear reactor?
Yeah.
Yeah.
Shreya, I hope making sense. Okay, now after that they're saying to you that, so over here, see, a control rod. Control rod, what is the function of a control rod? To absorb or stop the neutrons from traveling between the fuel rods. What is the function of the moderator? To slow down the movement of the neutrons. Shielding is usually made from lead because it prevents irradiation of the workers, it prevents harm to the workers. The fuel rod, the function of the fuel rod is to act as nuclear fuel or provide the fuel that is needed for the nuclear fission to occur, and the suitable material is uranium. Okay, heavy water is a compound of oxygen and an isotope of hydrogen called deuterium. You guys know what is deuterium? Deuterium is, remember the isotopes of hydrogen I taught you guys in our class in nuclear fission. Sorry, fusion. In nuclear fusion, I told you guys that we have two isotopes. One was this, right? And one was so one of the this was one of the isotopes, and another isotope I taught you guys was this one. This is known as deuterium and this is known as tritium. Okay, so these are isotopes of hydrogen. So question says state the meaning of the term isotope. Shreya, can you tell me what is an isotope?
An isotope is an element that has the same number of protons but different number of neutrons.
Okay, all right. Then they're saying explain the difference between nuclear fission and nuclear fusion. Viraj, can you give me the difference between nuclear fission and nuclear fusion?
Which question are we doing? The third one.
The second one, explain the difference between nuclear fission and nuclear fusion.
Oh, okay. So, like when you split a nucleus, yeah,
Yeah,
that's nuclear fission, and when you like join two nucleus, right, to form a larger nucleus, that's fusion.
yeah, correct. So nuclear fission is when you are breaking down a large nucleus into smaller nuclei, and nuclear fusion is when you take two small nuclei and join them together to make a larger nuclei. State a location where nuclear fusion takes place. Shreya, where does nuclear fusion take place?
So
Okay. Viraj, do you remember where nuclear fusion takes place?
Oh no.
Nuclear fusion takes place in our stars. Okay? Nuclear fusion takes place at our sun, at any star in our solar system, in our galaxy, in our entire universe. That is where nuclear fusion happens. Nuclear fission we can do on the on our nuclear power plants. That's where we do nuclear fission. But we cannot do controlled nuclear fusion. We can't do stable nuclear fusion over here on our planet, as in we cannot do it personally. Nuclear fusion happens where? It happens on the stars. It happens in our sun. Our sun is a star. So it happens where? It happens on the stars. Okay? Now they're saying explain why fusion cannot take place at low temperature, low pressure. In the stars, in the sun, we have a very high temperature and a very high pressure. That is the reason nuclear fusion occurs. Why will it not take place if the temperature is low or if the pressure is low? Any idea? Can anybody tell me why is it that I cannot just do it at a low temperature or pressure? Why do I need to provide very high temperature and very high pressure? That is the reason this only happens on our stars, because at our stars, the temperature and the pressure is high enough for this to happen. I'll give you guys a hint. Think of it this way, that we have, what is nuclear fusion? Nuclear fusion is when two nuclei are joining together to make a larger nucleus. So think about it this way, that those two nuclei, both of them are going to have the same charge, right? Because their nucleus only has protons inside it. I mean, it has neutrons, but it has protons. Protons have a positive charge. So both those nucleus are going to be repelling each other, right? So to fuse those nucleus together, to make them join together with each other, we need to provide a very high amount of energy, so that the two nucleus and high pressure and high energy is needed, so that the two nucleus actually join together and fuse together to make a larger nuclei, right? Making sense, Virat, Shreya? Why? So nuclear fusion only happens where? At the stars. Okay. And the reason it only happens in the stars is because we are trying to fuse nucleus. In nuclear fission, we just want to break it, right? And how do we break it? By throwing a neutron at it. So that neutron, by the way, has no charge. So it will, easily go towards the nucleus. But over here, I'm taking two nucleus and trying to force them with each other. Both of them have protons in them, so they both have a positive charge. So obviously, they're going to repel each other. So we need a very high temperature and a very high pressure to actually cause them to fuse and for nuclear fusion to occur, right? Making sense to everybody?
Yeah.
Viraj, Shreya, making sense?
Yeah.
Shreya, making sense?
Yeah.
All right, great. All right, guys, so we will go ahead and stop it over here for today. And we will continue with our questions in the next class. All right?